Scientific notation. Seems like scientific notation is going to be a big deal in years to come. And it's important for you to understand scientific notation because I know each and every one of you is going to be a famous microbiologist, and you're going to be studying the atoms and how proteins work in the body, and you're going to have to measure things that are super, super small, and so you need to write in scientific notation. Or, in my view, even cooler, you can be an astrophysicist studying the solar system or the universe, and you're going to be dealing with numbers that are huge. And so you're going to have to write them in scientific notation so that you can describe distances and sizes and masses. So that's how you're all going to use them, either one way or the other, right? So.
Or you could be counting all your money.
Or you can be counting your money. Caden's going to be counting money. The rest of us will be toiling away in the universe or looking at cells. Okay. All right. So it says one type of ant weighs 3 times 10 to the negative 3 grams, and it can carry on its back something that weighs 1.5 times 10 to the negative 1st gram. Which one's bigger?
The second one.
The second one, the weight it can carry. That's kind of amazing. I mean, I like to lift, but I'm not sure I can lift this much times my body weight. It's a lot. But how much? How many more times? That is the question. So there are a couple ways you could go about this. I'm going to show, or we are going to show 2. Could someone tell me, how do I translate this into standard notation? How do I translate this into standard notation? Lucy. Okay, so how many times do I need to move my decimal place? Okay, I need to move it 3 times. 1, 2, 3. Somebody needs help outside. Very, very serious help. All right, so then for my other thing, for the weight of the food, how do I translate this into standard notation?
You move the decimal place over 1 to the left. Okay,
so really we have 0.003, and we want to know what we have to multiply that by to get 0.15. Okay, so one way of doing it is to actually do that division. That doesn't sound so much fun. That's how you did it? Okay, and you would find, so when you divided, so what did you divide, buddy?
I divided 0.15 divided by 3 thousandths.
And you did that without a calculator.
All you have to do is like take off the decimal places and you have 3 and the 150.
I know. So in other words, you have the 0.15 here, you have the 0.003, and so you would have to move the decimal place 3 times. 1, 2, 3. And then figure out how many times does 3 go into 150, which is a grand total of
50.
This would not be a calculator problem. So it can carry 50 times its body weight. Think about it. For 100, if you're 100 pounds, that means that you would be able to carry 5,000 pounds. Craziness, I know. The other way that I would probably have done this problem is a little different, so I'm going to show it. It's going to make more sense for the 8th graders, but it's never too early to show you fun stuff. So we have 3 times 10 to the negative 3rd, and we have 1.5 times 10 to the negative 1st. Well, I personally would break it into 2 parts, and I would multiply the 2 parts together when I'm done. So I want to find the scale factor. What did I multiply 3 by to get 1.5? Oh, 0.5. Okay. So in other words, what I did was I said 1.5 divided by 3 equals 1/2. Does that make sense? Well, that should work on the other side of the multiplication too, right? I can just say 1 or 10 to the negative first divided by 10 to the negative third. And when you divide base something with the same base with exponents, what do you do with the exponents? When you divide by something with the same base and you have exponents, what do you do with the exponents? You subtract them. You subtract them. So we have 10. What is 1 minus negative 3?
Negative 1. Negative 2.
This is when I'm embarrassed for you.
Positive 2.
Positive 2. Oh, well, what is 10 squared? 100. So really, I just have 0.5 times 100, and that equals 50. Now, that way, I don't have to worry about the decimal points, which is why scientific notation is so useful. It provides you a way of describing things without getting caught in the minutia of unbelievable numbers of decimal points.